Hey, it's Mrs. Wheathy back for Unit 1 video lesson number 11 on significant figures, one of my favorite lessons. So, throughout the course of chemistry, we're going to be making lots and lots of measurements, and we have to understand what is involved with a measurement. So a measurement by definition is the quantity that has both a number and a unit. And so what do I mean by that? For instance, if you have the number 12, well, what does 12 mean? Is it 12 grams, 12 milliliters, 12 centimeters, 12 cherries, 12 elephants? We don't know what that quantity represents unless you have a unit that comes after it. So a measurement has both the quantity and or is the quantity that has both the number and the unit that follows. Now, when we make measurements, the precision of the measurements is very, very important. It's limited by the instruments that are available. The precision of the measurement is indicated by the number of digits that's reported. So for instance, look at this. You have 3.52 grams, 3.520 grams, and 3.5. That last digit is the precision or the accuracy of the measurement. It tells us how good that instrument really is. So this balance right here can only measure out to 1/10 of a gram. This one can measure out to 10,000th of a gram or 1,000th of a gram, and this one to 100th of a gram. So which one is the most precise? And of course it would be this middle measurement that we have right there. So the last digit indicates the precision of the instrument, but it's also the estimated digit. So if we take a look at this, we have a pencil that we're going to measure, and what we can look up, if we look at this close up, we see that for sure this pencil measures 4.7 centimeters. What we can do then is estimate that last digit. So some of us might read this as 4.72 or 4.73. But nonetheless, we have this very last digit, the 2 or the 3, okay, in the hundredths place, that is the estimated digit. So when we're looking at significant digits or significant figures, we're looking at all the digits that are known for sure. In this case, the 4.7 is known for sure. Those are certain. Plus that last uncertain digit where we have to estimate, what that last digit is. That is by definition significant digits. Okay, so you're going to write this down into your chill. Definition for significant figures: all known digits of a measurement plus one estimated or uncertain digit. Now we have rules for counting significant figures, and I usually kind of condense these and make them a little shorter than what's written in the textbooks. So the first one that we have here is non-zero numbers are always significant. So what do we mean by that? Let's say we have the number 15. Well, those are both non-zero digits. So we would have 2 sig figs or 2 sig digs for significant digits. This doesn't want to go. So 2 sig figs. Let's take a look at this one. We have 7,451. I should probably put the unit, let's say centimeters. And so in this number, they're all non-zero numbers. So here we have 4 significant digits. Okay, the next rule we have is zeros between non-zero numbers are always significant. And that just kind of makes sense. So if we have a number like 104 milliliters, that 0 in between the 2 non-zeros is significant. So you have 3 significant figures. But if you had something like this, let's say 20.13, and this is a 2 right here, You have a 0 between two non-zero digits. You have a decimal there, but it doesn't really matter because that 0 is between two non-zero digits. You still have 4 significant figures. Okay, the next rule. Zeros are significant if, and there's 2 parts to this, and the 2 parts have to be true. Zeros are significant if they follow a non-zero digit and there is a decimal. All right, so some examples here. We have the number 10. Okay, so you have the 0 here. Is that 0 significant or not? And follow the rules. Zeros are significant if they follow a non-zero digit and the 0 follows the 1 and there is a decimal. No decimal, so you only have 1 significant figure. But as soon as I put in a decimal, now that 0 becomes significant and I have 2 significant figures. If I add another 0 and I have 10.0, this 0 after the decimal is also significant. So any 0 that follows the non-zero digit and you have the use of a decimal is going to be significant. So in this case we have 3, 1 and 10, 2 and 10 with the decimal point, and 3 and 10.0 with the decimal. Now let's take a look at this. Another rule, placeholder zeros are not significant. So for instance, what do I mean by that? We have 0.00150. Okay, now this 0, the last one, follows the 5, follows a non-zero digit, and there is a decimal. So this 0 is significant. Well, what about these ones that come before the 1? Well, that doesn't follow the rule. They're before the non-zero digit. So these are place-holding zeros and they're not significant. So our only significant digits that we have in this number are the 1, 5, and the 0. Now you have to have these zeros here to give value to the number. If we didn't, then 0.150 is significantly different than 0.00150. Let's take a look at a large number. So we have 10,000. That's a comma. Okay, so follow the rule. The zeros all come after the 1, but there's no decimal. So that 1 is the only significant digit. Let's say I wanted to have 3 significant figures in this number. So that would be the 1, 0, and this 0 here. Well, I can't put a decimal after that 0 because if I do, now all the zeros are significant and then that changes your number from 10,000 to 100. But if I put a line on top of the 0, and this is where it differs from math class, that bar on top of that 0 does not mean to repeat that number. What it means is that all the numbers up to and including the 0 with that bar are significant. So now I have 1, 2, 3 significant digits. Okay? Now the last thing is that counting numbers and constants have an infinite number of significant figures. So as far as our mathematical operations, we don't use counting numbers and constants when we are considering the number of sig figs to round to when we do our mathematical problems. Okay, so let's go on to rules for rounding using significant figures. If the number following the last sig fig is 5 or above, then round up the last significant figure. So for instance, if I have 1.0245 and 4 is my last significant figure, we have a 5 after the 4, so that 4 will round up to 1.025. But if the number following the last sig fig is less than 5, then we're not going to round. So if I have 1.0243 and 4 is my last sig fig. 3 follows the 4, so I am not going to round that 4 up. My answer would just be 1.024. Okay, let's get into some mathematical operations. I think this one here, the rule for multiplication division, is the easiest one. You're going to round the answer to the fewest or the smallest number of sig figs among the numbers that are being multiplied or divided. Okay, so if you have something like 5 times 5.0, here in 5 you have one significant figure, here you have 2. So you have to round your answer to the smallest number of significant figures amongst these numbers that we're multiplying, which is only one significant figure. Well, everybody knows that 5 times 5 is 25. However, 25 has 2 significant figures. We only need one, which is the 2. There's a 5 after the 2, so the 2 has to round up to 3, and then we have to put in a place holding 0. Make sure you use those place holding zeros. So 25 can't round down to 3. It can only round up to 30. So it has to make sense to you. Alright, so this is where math and science kind of, butt heads a little bit, because, 5 times 5 is 25, but when you only have one sig fig, then it is 30. But if you had 5.0 times 5.00, then you have 2 significant figures. Here we have 3 significant figures. You want to round your answer to 2 significant figures, and your answer is then 25. Okay, and why do we do that? Because it reflects the precision, the accuracy of the measurements, the measuring device we are using to make our measurements. Now you only use this. Significant figures are only used in measurements. You're not going to use this to do an algebraic equation. You're not going to use this to balance your checkbook. We use this when we're making measurements. Let's take a look at this one. We have 100 with a decimal point divided by 10 with the decimal point. So 100 with that decimal point is, think about it, how many sig figs? Yep, 3 significant figures, and 10 with the decimal point is 2. So 100 divided by 10 is 10, but you have to make sure that you have 2 significant figures. So we can either put a decimal point after the 10, or we can put a bar above the 0. So it's either or, either a decimal point or a bar above the 0 to show that you have 2 significant figures. Alright, so our last is the rule for addition and subtraction. Now I think this one is a little bit more difficult. What you want to do is you want to align the numbers in the problem, then underline the last sig fig in each number. Then round the answer to the place value that is farthest to the left, or the largest place value amongst the underlined digits. So let's take a look at what that looks like. We have 3.725. That's a 7. And we're going to add that to 4.31. and add that to 110 with the decimal place. Now line these up right underneath each other. So we have 3.725, 4.31, and 110 with the decimal point. Next, what I want you to do is I want you to underline, let's underline the last digit, significant digit. So here we have a 5, here we have a 1, and here we have the 0. So when you add these up, you are going to round your answer to the digit, the underlying digit, okay, the place value that is farthest to the left. So here we have 1,000th, we have 100th, and we have the ones place. When we add up, we get 118.035. The place value, the place that's furthest to the left, is the ones place, so our answer will simply be 118. Okay, so that, my friends, is the end of video lesson number 11. I hope you love significant figures as much as I do. This is Mrs. Wheathy. So long for now.